Now things are getting real. Greetings, the Astro30 here yet again, and this is going to be a short video because I was hoping that this was going to be an assembly kit, but it's already pre-assembled. Oh well, it takes kind of the fun out of it. I was hoping to make a video of assembling one of these. This is a DSO138 and it's made by JYE Tech, just like the DSO150 is. I'm going to order the shell, the acrylic shell that goes for it, separately later, but not right now. So I will make a separate video on putting this in a case just to protect the electronics. But this got sent to me today. Today is the 28th of December. This isn't going to be released till after January. So anyway, what we should do is we should power this up, see if it's been calibrated, and then test some things with it. Now they did send me a manual with it. I don't know what the hell they've been doing on it, because there's all these pinholes here. They must have been assembling the damn thing on top of the manual. So this is the how to use section. Now that was what was at the front, but this should be the assembly instructions. Indeed. So if you're building one of these, this is what you'd be going through. It tells you what order to solder components in, and the LCD board already comes pre-assembled, so you don't have to do much with that. And it just goes through and tells you what all the voltages should be. Now I'm hoping that these have all been tested beforehand. I don't know if this thing works, but the neat thing about this is they've included the schematic for it, which is nice. So down here is the power supply. They're using a LM1117-3 to produce 3.1 volt, I believe that says, or 3.3. I can't quite see from here. I think it's 3.1. They're using a couple of transistors here to produce voltage positive, and they're using a 79L05, so that's a negative voltage regulator for 5 volts to give us our negative supply. And that's another way you can produce a negative voltage. Up here's our analog input circuitry with our range selection, a few op amps, and etc. The MCU section, and finally the LCD module connector. So you've got all the circuitry layout there to fault find if it doesn't work. Now it comes with these standoffs, which obviously are for the case, which I do not have, and this clip lead test lead. So what we need to do is power it up and see if the thing works. First I will connect the BNC connector, and then I'll find a power supply for it, whatever I've done with that. Okay, I'll use this 9 volt DC adapter that came with the other DSO that no longer works. It fits perfectly like a glove. Now I'll just plug it in. I don't know if this has a power switch yet. Apparently not. Well, it looks like it's picking up something. So currently we're picking up about 200 millivolts of noise, which is okay. Currently we're on DC coupling, so I'll change it to AC coupling. We're on 1 volt per division at times 1, times 2, times 5. So I'll leave it on times 1, so it's 1 volt per division. Just touching the ends of the lead with my finger, we can see that it's working. I'll go through its basic functions in a minute, but what I'm going to do is I'm going to connect up that function generator kit that I've already assembled and see what its output looks like. So I've got another one of these 9 volt adapters, but this is in reverse polarity, because I was using it on that crap G5 amp. So plug it in the socket and put that there, and I'll find a plug to plug this into. Okay, that's plugged in. So I'll connect positive lead the oscilloscope to the sine output and that to ground. And yes, we do. Now I have to select our time base. Now we are clipping, so I'll turn the amplitude down of the generator. Yes, it is producing a sine wave, which is nice. This box is upside down, and we're getting 3.45 volt peak to peak out, which is fine. So before clipping, we are looking at a maximum output voltage swing of about 3.8 volt peak to peak off of this, which is fine. So now I'll change this to triangle, and that in no way looks triangle to me. Oh, well, it does if you reduce the amplitude. So the maximum you can get from triangle is 3.16, I'll say, volt peak to peak, which is not bad. So now I'll put this on back to sine, and I'll test the square wave output, and I'll change my voltage down, my volts per division. We're getting a healthy 8.06 volt peak to peak out on square, and the amplitude control does absolutely nothing to it. Yes, the frequency does adjust. So that's fine. So I'll stick it back on sine, increase the amplitude, reduce my thing down to ×1. Okay. We can actually increase that even further by going on to 0.1 and doing that. So yeah, that little DSO is working quite fine. Just increase my time base a bit. There we go. And yes, we're getting a frequency increase. We're now currently at 900 odd hertz, and we are roughly now at 1 kilohertz. Yay! Now they do have a test output. There is supposed to be a link wire on these 2 points here, but they haven't included it for some reason. So what I want to do is turn that down. It looks like it has been calibrated. I do want to figure out how you actually adjust the position. I thought you could actually move it, like move it. Oh, you can. Huh. Right, so all you do is you press the plus, up and down button. Let me connect that back to a function generator so we can see the line without it wiggling around. You just press the plus or minus buttons and it moves the trace up and down. It's a shame it wasn't an assembly kit. I would have had fun putting that together, but it is what it is. Anyway, I'm back in business. I now have a working DSO. Anyway, this is the Astro 30. If you enjoyed this video, please remember to like, comment and subscribe below. And you can always follow me on Facebook and support me on Patreon. I'll put a link in the description to where you can buy this on Amazon. It would be nice if I'd actually made a video of assembling it, but the instructions are pretty well straightforward. I'm the Astro 30, and happy oscilloscopes. I've really got to stop saying shit like that because it makes no sense.